Hello, everybody. I gotta find the right window here. That's not the right window. That's the right window. There we are. Now you get to listen to it forever. Hooray! Question mark. Welcome to the lab lecture. The point of the lab lectures is to kind of give you a little bit of a walkthrough about what you're going to be doing for these other assignments that are part of the class that we would normally make you do in a laboratory setting. Like, the whole point of this, in my opinion, is to get you into a room where there's a bunch of equipment that you may have never seen or used before and develop proficiency in using it. That part's not going to improve this quarter because you don't get a chance to go to the laboratory. So unfortunately, there's not really a way, short of like you buying your own laboratory space or kit or something, to develop laboratory technique. The best compromise that we have in an online pandemic situation, I guess we'll say, is for me to do the experiments for you and just explain the technique as we do it. For this first experiment, the technique that you're going to be practicing is just simple observation. By just looking at things, you can deduce a lot of information about them, but you do not ever get the complete picture. But by subjecting things to a series of tests, you can develop a more robust profile that can help you identify what's what. First, we got to talk about how to get to all of this and what we're going to do with it. So, these lab worksheets are assignments, so that means that they will be graded. Unlike the regular worksheets that you find in the chapter section. So if you scroll down to like the units, Unit 1, here's your worksheet and here's your key. These are just for fun. You do not have to turn these in. The lab documentation, these you do have to turn in. And they will have a deadline 1 week from the date that you turn in, or that I assign the lab. So what I'm going to do is I'm going to post an assignment, and the assignment will say, please upload a file. And when you finish the lab, you're going to upload that file to that spot, but you have to do it in a certain way, and the point of today is to show you how to do that. So the first thing you want to do is you want to have access to this. I've spoken with a few students who've told me, hey, I can't get to the slides, or I can't get to the lab stuff, how come? And if that's true, you haven't done the prerequisite. So remember, you got to take the orientation quiz and get 1 point out of 1, get 100% on it, and that will unlock everything. If you haven't done that yet, you won't have access to this. So we'll call that step 0. Step 1 is to click on the worksheet and open it up. Let's see, another question. Is the quiz coming up about the stuff we learned in the slides? Yes, it's chapters 1 and 2. or units 1 and 2. Yeah, if you made a mistake on the orientation quiz, then you won't have access to all this stuff, and it'll lock you out. So make sure that you double check that. All right, so I've opened the PDF, so that's in this tab. I'm just going to use it from this screen. So you should see a worksheet like this. You'll know you have the right worksheet if you see a cat and a rat and then 2 white solids. You see 2 worksheets. You see all the lab worksheets except the first one. I might know what that problem is. Hold on just a second. Do you know what section you're in? Oh, it's under worksheet 5. Oh, I just didn't move it then. That's a mistake. So let me... Oh, look at that. That's bizarre. Hold on. Let me fix this real quick. That was not at all how I saved it. Okay, so that was section A. You get to see what I have to do in the back, which is basically me moving stuff around. Wow, it did this for all of them. That's bizarre. Okay. I think what happened... Oops, where did I put it? There it is. Is when I tried to... That's not right. Hold on. I think what happened is that... So, here's a little inside information about how this works on my end. So, I have what's called a blueprint, because there are 4 different sections, and they're all the same, but Canvas doesn't merge them all. Like, I'm not allowed to make them all into one section. So what I have to do is I have to use what's called a blueprint, and when I upload stuff to the blueprint, I then hit a button, and then it sends it to all of the sections and matches them up. Okay, so that one should be good. But Canvas being Canvas, it doesn't always do what you expect it to. So this is probably one of those times. There we go. That should be good. The recommended reading is always helpful to read. So make sure that you are doing that to further your understanding of the content. Okay, so now when you go back and check, and we'll do this again here, there should be a lab assignment 1. Yeah, and it's saved that time. All right. So let me know if it's not there, because it should be there. Okay, cool. Because there's another button that I might have to hit, and that is... So over here, you see these green check marks. If I push this, for example, the entire lab section for this course page will disappear. You won't be able to see it. And sometimes those don't turn on their own. They're not toggled on by default, which is really frustrating. So anyway, here's the lab documentation. The way that this is going to work is you're going to download this file. You're not going to turn in this file. This is just something you're going to read. It contains the directions on what you need to do, as well as pictures of fuzzy creatures. You read through the directions, and then you're going to get to parts where it starts asking you to answer stuff. For example, there's a section called Pre-Experiment Questions, which is just questions to answer before you watch the video on the experiment. Okay, so there's some questions here that I will expect for you to create some sort of answer for me. Now, where do you put those answers? And the answer is, well, we go back to the modules page, and we click on Google Sheet for lab number 1. So we'll open that in a new tab. And this one we definitely want to open in a new tab by itself. So you want to click up here where it says Google Sheet for lab worksheet number 1. And I see that there's already 5 people in here. So that's good that people are finding this. This right here is the worksheet that you're going to be turning in. But as a lot of you probably noticed trying to type into it, you can't. Right? The reason for that is this is the copy. This is the part that everybody gets. And if you edited it, everybody else would see those edits, and you would just basically turn in one worksheet as a class, and that wouldn't work so well. So here's what you need to do, and this is described in a separate document that I'll show in a second here. First thing you gotta do is go to File, and you gotta make a copy. And it's gonna ask you to give it a name, and so you want to just call it whatever you want. It doesn't matter, but you're gonna save it to your drive. Don't share it with the same people because they don't need access to your lab report. And there's no comments, so you don't need to copy those. So you hit OK. It'll open a new window. And this one you'll be able to type into. You can type whatever you want to. Okay? Some things about the worksheet. First things first, at the bottom down here, which you can see, are the tabs for the experiment. Each tab has different spaces for you to enter stuff into. Make sure that you don't just answer the questions on the first tab and then turn it in, because if you miss pages 2 and 3, you won't get credit for them. Any box that is labeled in light blue and a bold border requires your input. Okay? I have color-coded the worksheet so that you only have to enter information into the boxes that are blue. If you put information anywhere else, like over here, like these are some notes that I am taking, you can do that. Oh, you can't even see that because it doesn't scroll that far on the screen there. So let's say you just wanted to write some stuff in here. That's great. I won't grade it. And the reason for that is I only have certain spots that I will be looking in to assign you a grade and assign you credit, okay? So make sure that you are putting anything you want me to see in the boxes that are marked. Don't write anything in this gray column. If you do, you might overwrite some of my formulas. I've basically set this up so that when I grade it, okay, I'm going to give you a point for that. Okay, I'm going to give you a point for that. And you'll see that the score is incrementing up here, so that at the end, I can just give you a point. Oh, I'm going to give you 1,502 points for that. That's amazing. It's only worth 20 points, or 25 points, so. All right. How do you find out what section we're in? My schedule only has the numbers. So you can write the numbers in if you'd like. What I've learned is that when you upload, it'll automatically upload you to the correct section. But if you put 2534 or 2536 or whatever, that's totally okay. I can figure it out from that, as long as I have something. How do I go to the next page? There are tabs down here at the bottom. So where it says pre-experiment and then experiment, you can click on whichever tab you want. And then analysis questions. The first lab has 3 tabs. Some experiments may have more than 3 tabs. Some may have fewer. There will always be some number of tabs, and those tab titles will match up more or less with the documentation. So pre-experiment questions is pre-experiment. I do have to shorten the terms a little bit because I know if I go over too many characters, when I download it, it changes all the names. And that's no good. There is a character limit on tab names. Again, do not write in the gray column for any reason. And if you write your names, Wes, and then what section am I in? I'm in section pineapple. And then when you go to the next tabs, those will automatically fill because I have programmed to do that. So just fill in your name on the first page. Make sure you put your entire name, actually. Because when I look in the gradebook, if I just see Sam, I'm like, who's Sam? I have 6 Sams in my class. And that's no good, okay? So I do need your first and your last name on these, okay? So these would be the pre-lab questions. So you would read the documentation. And it says, according to the profiles, what observations are expected when substance C is mixed with reagent 4? You would type in the box whatever your answer is. So I think popsicles are delicious when melted. I don't know. Whatever you want to. You can type your answer in there. Obviously, you should type in the answer that answers the question. If you write random nonsense, then you'll get random nonsense for a grade. Should we do the worksheet first or the good sheet? I'm not sure what you mean by the good sheet. All of the sheets are good. Sorry, can you be more specific? Oh, the Google sheet. Okay. So first you definitely want to read the worksheet, because the documentation on Google will refer to it. For example, here's this giant chart, and it doesn't tell you anything to do. And there's more below here. The documentation, however, tells you what to do with that. Okay? And it also gives you a link to a video to watch. We're going to talk about that in a second. So, read through the entire laboratory PDF first, then go and make a copy of the Google Sheet, and then start answering the questions once you've read through it in its entirety. Don't just assume what's going on, because it will actually take you a lot longer. Like, you'll get there eventually, obviously. But if you don't understand what the sheet is trying to make you do, then when you get to this documentation, and the documentation doesn't have all of the worksheet info on it, due to, like, me trying to save space. Otherwise, this thing would be, like, thousands upon thousands of lines long. So I do abbreviate heavily in here. Okay. I'm going to delete all that. Going back to this worksheet, for the experimental section, I link you to a video. The video is unlisted because I made it, and I don't want the internet to laugh at me. No, not really. It's unlisted because I don't want people to use it without credit, and I don't want people to find it just accidentally. So the point is, it's just going to be used for this class. So if you go to Google, and hopefully this will work here. Yeah, this is my video. You can see me, and you can see all this, like, video game stuff over there, because YouTube is now recommending video game music for me to play for you guys. And so this video goes through the process of making observations. And so I recorded this, which means it's extremely cheesy. And I even wrote the music. And I'm not going to play it in its entirety, but the point is, here's some unknowns. That's a really terrible shot for me to pause on. Let me just open my eyes here. Here's some unknowns. We're going to identify them by mixing them with known chemicals, okay? And so I go through the process of mixing a bunch of known chemicals together, and then I ask you to record the observations. I wish the video quality was better. Unfortunately, I realized after I was reviewing the footage, after 3 hours of recording this, that it didn't autofocus. You can see that the faucet in the background is extremely clear. The stuff that I care about, not so much. So do the best that you can, and I have some suggestions for that in the worksheet. But they're along the lines of, like, check yeah, I am wearing blue camo pants. They match my lab coat. So things that you're going to want to check for when we're doing observations are listed on this worksheet, and I'm actually going to talk about those right now. So the point of the lab, yeah, we're going to go over that right now. The point of the lab is to make observations, and I'm going to want you to make observations in 4 different criteria. So the first is color. So, for instance, what color do you see for the solutions? Keep in mind, clear is not a color. If there is no color, you say that they are colorless. Okay? Or no color, that works too. So, color refers to what color would you assign to this. Something can be clear and blue. For example, this solution right here, it's hard to tell, is clear and orange. How do you tell if something is clear, as in it is transparent, light goes through it? And what you're going to do, and here I'll hit play on the video here so that you can see this. You can kind of see how behind the tubes, light passes through them and then hits the paper. That can only happen if the solution is transparent, whereas for some solutions, light can't do that. For example, this third one, light can go through. You can see it in the paper. For the fourth one, light can go through. The fifth one, not so much. So, I wish this was more clear, I wish it was more in focus, but use the paper on the background to help you determine opacity. If something is opaque, the light won't go through it. If something is clear, the light will go through it. And you can use the word clear or transparent. So something can be clear and colorless, but try to avoid describing something with no color as clear, because that is misleading. So those are the first two qualities, color and opacity. The third quality is texture. Is there a solid inside? Can you see it? Is it chunky? Did it make like a gel? Is it cloudy? Can you see anything that's obscuring the tube? So that's the third one. The solid may settle to the bottom of the container. I try and hold up the tubes after each one so you can see that. If you let the solids settle for a while, they may do that. And I let these sit for about 2 minutes or 3 minutes or so, because you'll see I'm just running around doing other stuff in the background. And then the last thing that I want you to describe is some other quality about it. So that would be like a visual cue. So you can describe this as anything that you want. So you could say something like, oh, it looks like applesauce, or it looks like blue jello, or it looks like cat vomit. Something that makes you think of this later on when you go back to look at it. Okay? In the worksheet, you're going to be filling in that information in these 4 columns. So let's try and describe this first one here. So this first one's not very exciting, obviously. So I would say that, okay, I have mixed the first chemical with the first sodium substance. And so these are each the trials. They go vertically. This top chemical is what I mixed in, and then these are each of the 5 nitrates, tubes 2 through 6, as shown in the video. So I would say, okay, what color is it? Well, it doesn't have a color, so I would say it's colorless. You do not need to use the Canadian spelling of colorless, that's fine. What opacity is it? I would say it is clear. Record the texture of the solution. There is no visible texture. And then for a phrase or descriptive term, I would say, looks like water. Or something like that. Yeah. I'm just using your guys' answers. So there you go. That's an observation. So now I would go to the second one. And this one is like blue with a gel in it. So you could say, I don't know. It's like sky blue. And it's kind of murky more at the bottom. And some solid has formed. Whatever, right? No, I'm not going to drink it. They would all taste terrible. Also, I put these in the wrong box. So that's the thing that I just did. So those would go down here, actually. So blue-ish, semi, solid, Donkey Kong. 64. I don't know. Whatever. Right? So I apologize that these aren't going horizontally. I was copying them out of the chart that matches with the workbook, if you bought that. But in reality, I probably should have made them go to the right. There is another column over to the right, so just make sure you don't miss sodium iodide over here. But yeah, you can use whatever descriptive terms that you want. Now, you'll notice that there are boxes over here by themselves. These boxes are for the original solutions by themselves. Is it okay to use words like that, which may not be professional? For the 4th box, for sure. So, like, in the spot where I ask you to just make a descriptive term for your solution, you use literally anything you want. That's fine. For the first 3 boxes, try to be professional about it. Note that any color is professional, so if you wrote fuchsia, I'm not going to go, that's not a very professional color. Just say pink, because fuchsia is more descriptive than pink, so that's perfectly acceptable. For texture, I would say things like precipitate or cloudy or stuff like that. I would avoid words and texture such as smooth as silk. Like, that just sounds romantic and doesn't really describe anything to me. But that would work great in the 4th box, for example. All right. So these, again, these boxes on the side, these are for the solutions by themselves. I show you the solutions at the start of the reaction by themselves. So here they are being added. I'm really fast when I put solutions down, so you're going to have to do this quickly. No, I'm just kidding. You can pause the reaction at any time. In fact, I even tell you to pause the reaction by, you can hit the space bar or hit pause on the video. These are all aqueous chemicals, if that's what you're asking. They are all dissolved in water. Once you have finished the experiments on the screen, you can see that there's a bunch of them there. What I'm going to do is I'm going to take the unknowns that I was pondering at the start here. That's not the unknowns. They're there. And you'll notice that one is a sodium substance and the other two are nitrates. In the chart, what you will be doing is looking at the reaction of sodium substances with nitrates. The mystery sodium substance is one of these 5 on the top here. And yeah, I have too many regrets together. If I typoed that would be hilarious, though. So your unknown sodium substance is one of these 5 on the top. Your unknown nitrates are 2 of these 5 on the side here. Now, you can use any information that you have available in the video to identify what the unknowns are. Okay? At the end of the video, what I do is I mix the unknowns together. And so I mix the mystery sodium substance into tube 2, which is a mystery nitrate, and tube 3, which is a mystery nitrate. And I have results here. Be very careful with the colors of the unknowns in the results here. Okay? It is possible to determine the correct answer, but the differences are very subtle. Okay? I make a note of that in the lab documentation, that if you can't narrow it down to one choice, try and narrow it down to 2. And if you can get them both in the, oh, this is what I think they could be category, then that's fine. Okay? So you just have to get really close. Okay. Once you're done, then that's it. And then I give you a thumbs up, and then I just leave. And I play that music I've been playing at the end of lab all the time. There you go. You can see my pants. All right. That's it. That's all there is to the first lab. You're literally going to watch a video and then type in observations, and then answer some more questions on the analysis tab. Oops, I'm in the wrong thing. There you go. So this is the third page. It's going to ask you to type in the entire name. So the sodium unknown might be sodium, I don't know. I'm just going to type hydroxide. So if you think that that's what it is, type that in. The second one might be, I don't even remember what the reagents are at this point. There's so many nitrates out there. So just type in whatever you want for the names. And then at the bottom here, I want you to explain how you came to this conclusion. Now, your conclusion might take a few sentences, but I've only given you this much space. So what I want you to do is type out your conclusion, but keep it in the delineated space. How do you get to the other pages? There's these tabs at the bottom. Oh, you can't see them now. Oops, hold on. They're at the bottom right here. So where it says analysis questions, experimental, and pre-experiment. You just click on each of those, and that'll get you to the next tab. So no, you're not doing this on a shared doc. You are creating your own document by going to the File menu and hitting Make a Copy, and then using your own document. Okay? Because this will save a copy to your Google account, which you then have. Okay. Now, what do you do when you're done? Not dumb, I'm sorry. What do you do when you're done? That was a really unfortunate time for my lips to be parched. Sorry, I am dehydrated. I need to drink more water. What do you do when you're done with the experiment and you have everything ready to submit? Is using atomic symbols for specific stuff? Yes, that is okay. Something to note is that you cannot use subscripts in Google Sheets easily. So, like, if you typed in, like, I don't know, say you want to type in copper nitrate. Oops. That's the best you could really do without doing some, like, crazy detail. And I actually don't know how to do subscript on here. I don't think that you can because this is not a word processor. Specifically for these questions, I'm asking you for the name, so you have to type in a name. But if you're, like, describing something down here, You could say, oh, the nickel nitrate, and to go NiNO3 2 or whatever, or the iron nitrate FeNO2 or NO3 2, however that works. I put it in Excel. Does that work for turning in? No, do not put it in any other form. Use the Google Sheet. Okay. If you put your documentation in a different setup, my computer here at home will not read it, and you will receive a 0. Okay. You have to use Google Sheets. Okay. I had a student last quarter who kept doing that with Excel. She'd download Excel and put it in there, and then I'd try and open it, and it would say cannot open file. And for whatever reason, I could not open other people's files if they didn't use Google Sheets, okay? Keep in mind, I have 120 of these to grade every week, okay? If you cause me a hiccup in the grading, I chuck your file and I move on to the next one. You get a 0, okay? So you get one chance to submit it correctly. You have to do it this way. This is the only way that I have working because I need to keep the gears moving. Okay. How do you submit a file? Here's what you do, and this is very important. If you don't do this, I won't accept your file. Go to File, go to Download, and then you check this option right here, Microsoft Excel XLSX. This version is backwards compatible for the version of Excel that I have, which is ancient because Excel is expensive and I haven't pirated a very recent version yet. They haven't given me a up-to-date version. But this will work with my documentation. So you download the file to Microsoft Excel, and it will ask you, save the file somewhere. You save a copy to your desktop, and then there's a specific naming convention that you have to do. So then you'll just right-click on your file and rename, and you have to do it in a certain way. And we'll talk about that in just a second. Okay? But once you have uploaded the file, once you're ready to upload the file, you go back to Canvas, you go to Assignments, and I haven't actually made the assignment yet, so let me just quickly make an assignment here. So this will be a test assignment. All right, and so what will happen, let's see here, file upload, let's see here, XLSX, unlimited submission attempts. Can I assign to nobody? Oops, I don't know what happened there. Oh, that's what the problem is. Okay. Okay, so this is just in my practice folder, so this is not something that you're going to be able to see just yet. Let's see here. Where's my student view? There we go. Okay, so now what it would look like is you would go to the assignments, and you would see, oh, okay, I have a play student. I didn't publish it. Hold on. Boop. There we go. So what you would do is you would go to the Assignments tab and see, oh, I have an assignment. I need to turn this in. And there's this button right here that says Submit Assignment. You give it a file, and then hit Submit the Assignment, and then it'll pop up in the corner that, hey, it's done. Okay? That's how you upload the file. Yeah, do not use Excel. You must use Google Sheets, because if you use Excel to download my file, what ends up happening is two things. One, all the formatting breaks, which is no good. Two, I try and open your file, and there is a 75% chance that I just can't open your document because it's not backwards compatible. And then three, the real reason, if I have 120 people doing it exactly the way I tell them to, which is do it this way online, and I get 120 documents that are all identical, I can grade them and provide better feedback. Okay? If I'm trying to find where page 2 is because Excel does this or whatever and flips the pages around, or changes the color of all my blue boxes to orange or whatever, then it gets extremely frustrating to work with. Okay? I have to assembly line this, or I will never get your papers back in a reasonable amount of time. Because unlike your Canvas quizzes, I do manually grade these, and I read absolutely everything you write in blue. I put a lot of time into them. Okay? But I can only do that if you make it easy on me. So please, please, please use the Google Sheets. And if you're not familiar with them, I recommend that you learn how to get familiar with them, because businesses and companies are starting to use both Google Sheets and Excel. I personally like Excel better, but knowing how to use both of them is a skill you can put on a resume. So it's good to learn how to do that now. Okay? That's how you do lab number 1. So again, to review what we went over. Step 1, download the documentation, the lab worksheet, and then click on the Google Sheet link. Step 2, make a copy of your own page. Step 3, do the assignment. Step 4, upload as we have shown. What naming convention do you need to upload the file? Right here, there's a document called Lab Primer, how to upload completed lab worksheets to Canvas, which tells you basically everything that I just talked about. I don't need to be in the student view anymore. And it basically walks you through all of the directions that we talked about today. And down here, it tells you the naming convention. So the way that I want you to type in the naming convention is to do the following. So type in your name, last name first, everything in capital letters, put a hyphen, Chem 140, space, and then your section. That can be either LL, whatever, or the number. As long as I have one of those two pieces of information, I can then put you in the right folder. Okay. This is just because I need to make sure I have something on your document that puts you in the right lab. Because some people don't know what lab they're in, and they put the wrong thing, and so inside the documentation, so I move it to the right folder. And then when I get to the grade book, I find out, oh, you're in the wrong folder. Or maybe there's an issue with Canvas where like you're enrolled in OLC, but you have access to OLA or whatever. Canvas is weird. I have hit all sorts of crazy issues. Where do you find out your section? It's on your schedule. So if you go to your My EVCC, you can check your schedule, and it's the number that you're enrolled in. And it should say a section number as well. OLA, OLB, OLC, or OLS. The last thing I want to talk about before we go on to whatever it is that we're going to do for the rest of the day, or nothing if you guys want, is for lab reports, the urge to work with other people is very, very high. And I would encourage you to do so. However, you must submit your own work. Okay? What that means is that you cannot have one person do the assignment, send them a copy, have them put their name on it, and then upload it. If I get 2 assignments that have identical language, everything is the same, both assignments receive 0s, and I send your report to the dean. What that means is you get to have a conversation with the dean, explaining why you submitted identical reports and were basically caught cheating. Okay. ARR is the room. That should be like arranged or something. I actually don't know what it looks like on your end from the schedules, because I don't have a schedule. I have something that kind of looks like a schedule. Congratulations on your puppies, by the way. Sorry. How do you download a copy? So when you're done working on your assignment in Google Sheets, you're going to click File and then Download as Microsoft Excel. Don't use any other documentation because it breaks my formatting. If you download PDF, I can't type into it. That's no good. So what you are downloading is an Excel file, but what I don't want you to do is download the blank file as an Excel file and then work in that. And yeah, you can do that too for the numbers, okay? So easiest thing, do all of your work in Google Sheets, hit download as an Excel file, it will take all of your stuff and make it into the Excel language that an old version of Excel understands. Don't edit the file once you have the Excel spreadsheet on your computer. Just directly upload it. Okay, that is the best way to get around any compatibility hiccups that I'm aware of. Please follow the naming convention shown in the documentation right here. Okay, so you can refer to that on your own time. All right. Hopefully that answered everybody else's questions. When is the worksheet due? It is due a week from today, so Tuesday at 11:59 p.m. Actually, wait a second. I might have the day mixed up. It might be Thursday. Hold on. I don't know where the folder would be. I mean, I have a syllabus right here. I'll just click on it. When will the assignment for the worksheet go up? I'm going to do it during the 10-minute break we're going to take in just a second here. When are worksheets due? Oh, they're due Thursday. Okay, so you actually have a little more than a week. So I have on the syllabus when stuff is due. So this will be due Thursday at 11:59 p.m. And then on Friday, I'll do last call. So you have an entire week to do it. Okay. All right, so we're going to take our 10-minute break now. But before I go on the 10-minute break, here's what we do for the second half of the lab lecture day. So if you have no other questions, or you just want to check back on the video later tonight and see if there are any other questions, you're free to do that. So that would mean that we're pretty much just done. If you do have questions, what I want you to do is type them in the chat during the break. And by questions, what I mean is, could you go over this homework example? Or, hey, I don't understand this topic. Can we talk about it a little bit more? Or something like that. So I give you 10 minutes to collect any ideas in the chat. If after 10 minutes we don't have anything in there, I do a last call, and then we call the stream, and you go do whatever. Okay? So let's put the title card up for break time. I need the timer back up. So over the course of the break, let me know if there's anything that you would like to cover for the next period. We'll go up until 4 p.m. But if we finish early, we finish early. It's up to you guys, okay? So we'll start the timer. We'll start up the Zelda again. I gotta find it. Where'd it go? Here it is. And I'll see you in a bit. right, we are back. I had to do a little bit of setup. Let's see here. Problems 1 through 3 on the recommended homework exercises for Unit 1. So, where is... Oh, goodness, now I have a cat. Hi. Meow. Meow. Sorry, I have a cat. Where is the first page? So if I go to this, we'll go back to... Oops, that's the wrong one. So if you go to this page, you'll see that problems 1 through 3 is just kind of left there by itself. Over here, right above it, is a link that says recommended homework exercises. If you click this link, then it will take you to the OpenStax textbook. And what I want you to do is, in this text on this page here, do problems 1 through 3. So those problems that I've just highlighted are the 3 problems that I feel reflect the exercises for this chapter. Because chapter 1 is very, very basic. It's how do we science, right? Yeah. So that's how you use that. And it's going to keep telling me, hey, you can log in. I don't want to highlight. I just want to unhighlight. Okay, whatever. And then for Unit 2, same thing. Some of the problems, or some of the recommended reading has problems associated with it. So it'll just say some homework problems are included on this page. Basically, that means that if you click on this page and you scroll all the way to the bottom, there will be a bunch of exercises as well as the answers. Well, they may not be at the bottom. Oh, here they are. Here's a bunch of scientific notation problems. And so on and so forth. Okay? Yeah, I know how you feel about that. Unfortunately, I have to have you be able to refer to some sort of textbook. Now, keep in mind, you should not have paid any money for this textbook, because that's the point of OER, is that we're trying to provide it to you for free. What else do we have here? Oh, that's... Okay, yeah. So, specifically in this class, we've designed it so that you don't have to buy a textbook. Because it's for 1 quarter. That's silly that you have to pay $140 for that. Or whatever it costs. What else do we have here? I think that's just... We can go back to the questions. So let's see here. There was a question up here before I started talking about Zelda. And how terrible I apparently am. No, I had the worst game of Zelda I've ever played yesterday. I play a randomizer, so it just completely randomizes where everything is and all the monsters. And they just put everything bad on the overworld, so I just died 23 times in the first hour. Can we go over how numbers affect calculations? For example, 7H and 7I. So that's this tab, and what I need to do is capture... I gotta make this appear. Window capture 3. Okay. Well, that's what I want, but that's not where I wanted it. So let's do that. Actually, you know what? Hold on. Okay, now I can make it bigger. And I don't know why I'm trying to scroll there. There we go. That's what I want to do. So someone had a question about problem 7 on the worksheet. So here are some of the problems that I asked you to do. And now when I go to Photoshop, I should just be able to do this. Oops, that's not the drawing tool, but yeah, there we go. That's too big. Let me make the pen a little smaller here. 4. Cool. Okay. So, let's see. We want to look at 7H and 7I, and then I want to click on this so that we go back down to the chat here. All right. Oops, I'm not quite in the viewable region. Okay. So this problem is asking, and I'm going to do this to represent that this number is underlined on the thing there. So what this is asking you to do is do this operation and then report the correct number of sig figs. Underlined numbers are exact numbers. Now you'll notice that there are very few underlined numbers there because we don't really work with exact numbers that often, but sometimes you do. Okay. How many sig figs does an exact number have? Sideways 8 sig figs. Good. And then how many sig figs would this number on top have? Good. Okay. So what is fewer sig figs? 6 or infinity? Obviously 6, right? So I'm going to punch this in the calculator now. And the calculator says 2.104746. So I'm just going to keep the first 6 of those. 2.1047. Now the next digit is 4, but the digit that comes after that is 6. So I'm going to round it up to 5. There you go. So that's 7H. When you do 7I, I'm going to write it vertically here. Or actually, yeah, it's still vertical. So 438.2. Do exact numbers affect addition and subtraction in any way? They don't, because when you add an exact number, so we'll go over here and do that in red here. So if I added, say, this number to exactly 6, remember that exactly 6 would be like this, right? And that just happens forever and ever and ever. So you would always just report your answer to where the other numbers dictated it based on sig figs. The answer should keep all sig figs since 6 is an exact number. Yes, based on the number right here. Now, if I had a different number adding to that, so maybe like 4.1, then now this would be where I cut off my numbers. So it depends on the previous numbers. In other words, exact numbers don't affect sig figs at all because their last sig fig is over here at infinity, and we're never going to have to worry about that. Let's look at that for these problems here. So we're going to have to do some addition and subtraction here. So where am I going to put the cutoff line here? Well, I don't have a digit in this spot, so I can't use the hundredths place. We're going to stop at the tenths place. Then I'll do the addition like it was normal. And yeah, double check my math because I'm not that great at math. Here's the last digit I stop at, so I'm going to round this to 458.0. And that's the number that goes there. Let's do that for the subtraction. We're going to do the same thing. Which position do I work with? So here's a sig fig, here's a blank, that's no good. But here I have 2 sig figs, so I can work there. We're going to cut off our answer at that spot. And then we subtract like it was normal. 12 minus 6 is 6. 7, 6, 8. And that number goes there. So now the result of this becomes 458.0 over 86.7, which is a division problem. When I'm doing division, I keep the number of sig figs that is equal to the value with the lowest sig figs, right? How many sig figs does the top number have? How many does the bottom have? And how many should my answer of this problem have? So this guy right here has 4 sig figs. This one has 3 sig figs. How many sig figs should my answer have? Should have 3, and that's right. So I punched in the calculator, and I got a bunch of numbers, which I'm going to shorten to 3 sig figs, so that would be 5.28. There you go, you're all set. So that's how you do mixed operations. Whenever you have to change the rule from addition to, say, division, do one rule, then do the other. Solve your answer, and then do the other rule. And just keep doing that until you get to the end. Three doesn't have 0 sig figs, it has infinite sig figs. So this is an infinity symbol. There you go, no problem. I could see how you could see that as a 0, because it does look, if you didn't know it was infinity, it looks kind of weird. It kind of looks like I'm raising my eyebrow. Or something. If I do this, now I'm like one of those Among Us characters or something like that. I really want to play Among Us. If you've played Among Us, you know why I'm so excited. Why did we only have 3 sig figs in the last problem? So the reason that we have 3 sig figs is because when we get to this step, we're doing division. And of the numbers that are available, one has 3 sig figs and one has 4. Now, how did we get to this point? Well, we did addition and subtraction, and those rules don't follow a number of sig figs. So you do the problem, and then whatever result you get influences the next step. So you do have to do this stepwise. You can't just throw all the numbers in the calculator and hit enter. Because you'll notice that up at the top here, all the numbers we started with have 4 sig figs. And down here, our answer ends up only having 3. So do each step follow the sig figs rules, and then at the end, you'll get the correct number of sig figs based on whatever operation you're trying to do. Yeah, I feel like playing Among Us with my students would be a conflict of interest when I get the imposter. Because you know that's going to happen, right? I'm not sure I feel like I could stomach that, I guess we'll say. There was another problem up here. Hold on. I want to find it before we get too distracted. Let's see. Question 6. Oh, the table. Okay, so let's go to this table. All right, so, in fact, what I can do is I could just make this one. I gotta click over here. I can make this one bigger. So the question asks, okay, so I have this right here. This is 3 sig figs. What do I do to make it 5? And the answer to that would be, well, you can just type in whatever you want to that has 5 sig figs in it. There you go. So that would be acceptable. What else would be acceptable? You could also do this, or this, or even that, because they would all round to this value over here, right? Because when you chopped it down to 3, you would end up with 1.75, which is what this is. And I realized that this actually goes in this box here. And so I'd be like, 1, 2, 3, 4, 7, 4, 5, 1. There you go. So that would be a correct answer. But it turns out for this question, there are infinite answers. You could put in any answer that you want. As long as it fills in the table. When you have a row of these types of problems, as long as all the answers are consistent with each other, it will be accepted as correct. And also, I actually mentioned up here, there may be multiple valid answers possible, and so that's why. See, I feel like if we played Among Us, what would happen is every round it'd be like, vote out the teacher! Vote out the teacher! Yeah! And then there I go tumbling off the spaceship. Professor West was ejected. Well, if you all play Among Us together, you can have somebody pretend to be Professor West, and then you can just stab them or eject them or drop them in lava or whatever it is that you do. Are there other questions about... I'm just scrolling through the chat really quickly here. That seems to be all I got. Can we do more problems like the one where there's more subtraction division? Sure. Let me find... oh, I'm just capturing the middle of my document, not the top of it. So we can do some more of these. And I moved that on accident. So let's see here. So let me clear the screen here. And then I gotta find where my safe area to write is. There we go. I'll just move the page down. Okay. I don't necessarily need to do these problems, but I could pick a different problem. Homework is not graded, so the worksheets are not graded. The only things that are graded in this class are quizzes, labs, exams, and the final. You do get 1 point for your orientation quiz. What do I want to make up here? So let's do 842.638 minus 174.1. Yeah, it's worth it to do these. Once you get to college, you're just going to have to start doing problems just for your own benefit. Like, we don't assign points to everything because we don't have time to give out that many points. And also, doing homework isn't necessarily reflective of your ability to demonstrate that knowledge. Because if you're at home with infinite time and preparation, it's not a great way to gauge whether you know something or not. A better way to gauge it is to see you working on a problem in action and seeing your thought process. And so, like in the lab, I could tell really quickly if you've been doing the practice. Here it's a little different because we're not in the same room. All right, so when I'm doing addition and subtraction, first step is I got to figure out what place I'm going to truncate to. So am I going to keep my answer to this spot? Well, I have no sig fig in this position for this measurement, so no. Can I go here? No. Can I go to the 10th place? Yeah, I can because I have sig figs for both of them. So that's where I'm going to cut my answer off. Get rid of these arrows here. And then we're going to do the subtraction like normal. 8 minus 0 is 8. 3, 5, 8, 6. There you go. And then I will round my answer at that position. So that would be the answer to that problem. Now you'll notice that if we went counting sig figs here, this answer right here determined our sig figs because it determined what place we round to. But we also had the same number of sig figs. That is coincidence, as we're going to see in this next problem. You don't have to super confirm with me. If I put it in the syllabus, I intend to follow those rules. So, can you imagine if an instructor wrote your syllabus and then you asked them, so it says in the syllabus, is this what we're really doing? And they said, no, actually, you're going to do something totally different. Like, that'd be super frustrating, right? Like, why would you put it in the syllabus if you weren't going to do it? Well, we are going to do it, so that's why. No, the syllabus is contract. If there's a mistake in there, I have to actually change the syllabus, or I have to just follow what I have. So same process as before. Again, these are unknown numbers. Should I report my answer to this position? Well, I don't have a sig fig for this value, so no. How about the hundredths place? Nope. Still have no sig fig there. 10th place, again, that's where we're going to cut off our answer. Then we'll do the addition as normal. And then when I report my answer, I get this. And you'll notice that in this case, this number up here had 3 sig figs, but this number for our answer had 4. So the takeaway is that addition and subtraction care about places. Okay? So when you are figuring out the number of sig figs, the number of sig figs will be determined by your answer, which has some magnitude, and also the place that you choose to stop reporting answers to due to lack of precision. Okay? Addition and subtraction does not care about the number of sig figs in each value you're putting into the equation. Okay? That's multiplication and division. Okay? And so these are different. Okay? And that's where everybody screws up, because it's the first thing that you do is like, holy crap, this seems really easy, and all it's doing is taking everything I knew about adding and numbers and making it wrong. So just be really careful that you are not mixing up the rules. And the only way to get past that block, and I know everybody has this block, they want to do the one rule for everything, is to do all the problems that you can. So do all the problems in the worksheet, do all the problems in the online text for Chapter 2, and you should be in good shape. Would you use an instrument with less precision for the larger numbers? Yeah, that's pretty much it. So is that the one with the beaker and the... and the graduated cylinder? Yeah, so if you need a rough number, you don't need a burette to do that. So 42 milliliters could be plus or minus 1. A burette would be very tedious to do that, but a beaker would be just fine. If you need 500 milliliters of something... Oh, I'm sorry, I messed up, sorry. I forgot that I have a graduated cylinder there. For a graduated cylinder, you could get plus or minus 1 very easily. In fact, you can get plus or minus 0.1. So graduated cylinder would be great for 42. But for 500, and that's actually something that's very common in the laboratory. That's a issue where you like, okay, go to the hood and pick up 100 milliliters of the solution, because you're going to just hold it in the beaker. Beakers are basically for holding stuff. You don't really measure with beakers. Graduated cylinders are good for crude measurements, and burettes and pipettes are good for fine measurements. But since we're not going to actually get to work in the laboratory, that's just my attempt to, like, get you to see that in practice at least. All right. Are there other questions that we have? Any at all, let me know. Type it in the chat. Roll credits. Well, I need to actually give people a chance to type stuff in, so I'll wait a minute or two. Go ahead and type anything you want in the chat. If there isn't anything after about a minute or so, we'll wrap things up and we'll call it a day. Well, it seems like people are getting goodbyes ready. So, where's the thing that I was looking for? There it is. I have to get my little... I have to get the track for my little outro. Here. Hold on. There it is. So, we're going to wrap things up for the day. Remember that you can always email me a question by sending me a message through Canvas. Or you can email me directly. I'm happy to answer it. You don't have to just rely on these office hours for that. Thanks for coming out to the lab lecture. Make sure that you email me with any questions that you might have over the course of the week. I'll point you where you need to go for whatever resource. Make sure you watch the lab video. Make sure you read the how-to on how to download and access lab pages. And again, remember, please, please, please use Google Canvas, download the Excel file, and then send it to me. Make sure you follow that procedure, or else you run the risk of things all falling apart. And that'd be no good. Have a wonderful afternoon. And I will see you all tomorrow.